Hi students, welcome to the session on power radiated and radiation resistance of HC and dipole antenna. Before watching this video, please refer my video on radiation mechanism of HC and dipole antenna. Otherwise, this derivation is not will not be clear for you people, right? So how I am getting that all the data, right? So please refer that video before going through this video, right? The video you have to refer is radiation mechanism of HC and dipole antenna. Okay. So from radiation mechanism of HC and dipole antenna, we found H5. H5 is equal to I naught dl divided dl by 4 pi sine theta j beta by r plus 1 by r square e power minus j beta r. This is what we found. Okay, fine. So the radiation field is having only r, 1 by r is dominant, 1 by r squared is an electric field. So for radiation field, 1 by r squared is 1 by r only dominant. So we can neglect 1 by r squared. So H5 will be equal to J I naught beta dl divided by 4 pi r sine theta e power minus j beta r. I just neglected 1 by r squared term. Okay, fine. So we got H value. Today we are going to find what is power radiated and radiation resistance. So what is the logic we are going to use is, right, we are first going to find P average, right? P average is equal to 1 by 2 real part of E cross H, right? So from that we find P radiated. P radiated is equal to integral P average dot ds. Okay, so after that what we are going to do is, from that we find I. So this is what power radiated we are going to find. From that power radiation we can find R radiation. How P radiation is equal to 1 by 2 I naught square R radiation. This is the logic we are going to use in the derivation. So first we find P average. From P average we find P radiated. From P radiated we find R radiation. R radiation is equal to 2PR divided by I naught squared, right? Okay, let us start. So H only I have. So H5 component I have. So first we have to find P average. P average is equal to 1 by 2 real part E cross H. Okay, so that is equal to 1 by 2 real part E cross H is A cross B is AB sin theta, right? So A into B into sin theta. So E and H is always 9 perpendicular, so sin 91. So normal, unit normal is AR. Okay, so E value I know, sorry, H value I know, right? Then we know that the relationship between E and H is given by E by H is equal to eta. Yes or no? So instead of E, I substitute N into H, because from H only I'm going to find all the value, because H value I know. Yes or no? From E also you can find. Here I do with H. So I substitute E is equal to eta H. So power average is equal to 1 by 2 RE, RE not RE, eta EH, instead of E, eta H. So eta H square magnitude. We take magnitude, right? AR, P average vector. Okay. So what will happen? So now we know H value, we know what is H magnitude. Magnitude of H is given by J will be going away, right? So if you take magnitude, this is what, right? So what is mod H? Mod H is simply removal of J. Why? If z is equal to 2i means what is mod z? 2, right? So similarly for mod h, j will be removed, so remaining thing will be coming as it is as mod h, I not beta dl, like that, right? Okay, so that you must remember, so I will do later. Okay, so next thing is we substitute the formula. Now I want p radiated. P radiated is equal to p average dot ds, right? So AR, see, p average is along the r direction, that we know because we keep our antenna in the r direction, right? Hope you remember, right? That's what I told you to refer my video on HC and dipole first. The antenna is kept here in the r direction. So in r direction, what is surface area? That is given by r squared sine theta d theta d phi AR, right? So that is what surface area for spherical coordinate system, right? So if you have any doubt, please refer my video on spherical coordinate system. Now I substitute p average, right? So p average we can write as this one, 1 by 2 eta h square into AR. ds is given by dot r squared sine theta d theta d phi AR. Now if you take a dot product, AR dot AR is 1, so I put double integral. Let me tell you why. 1 by 2 eta, what is h? H is just magnitude, right? H is a magnitude. I told what is h value. H is given by I naught BDL by 4 pi r, right? What is the magnitude of h? From this we can find magnitude of h is equal to, j will be going away, I told here, I naught dl divided by 4 pi r I naught beta dl sine theta. E power j theta magnitude is 1, so it is simply I naught beta dl by 4 pi r sine theta. So instead of h, I write as I naught, h means I naught beta dl divided by 4 pi r sine theta whole square. AR dot AR 1, so r squared sine theta d theta d phi. Since integration is with respect to theta and phi, so we know in spherical coordinate system theta ranges from 0 to pi and phi goes from 0 to 2 pi. Substitute that value. Okay, so now if you simplify, what you get is, so integration is with respect to theta and phi, rest of the things will be constant. Take it outside. If you take outside, what will happen is I naught squared eta beta squared dl squared divided by 32 pi squared, then remaining thing will be inside sine squared theta into, so phi, there is no phi component, so integral phi goes from 0 to 2 pi d phi, theta goes from 0 to pi. What is the theta component? Sine squared theta, it is sine theta, so sine cube theta d theta. Okay, so now if you simplify, I naught squared eta beta squared dl squared divided by 32 pi squared, integral d phi into 0 to pi is 2 pi only. Here I have to integrate this, theta goes to 0 to pi sine cube theta d theta. What will happen? So I take that one specially and find the answer. Theta goes to 0 to pi sine cube theta d theta, I write as 0 to pi, this theta only, so I write as sine squared theta d theta into sine theta, that's what sine cube theta. Okay, otherwise I write here d theta will be here, right? So sine squared theta I write as 0 to pi 1 minus cos squared theta, sine theta d theta I write as d of minus cos theta, differentiation of minus cos theta. d of cos theta minus cos theta differentiation is sin theta d theta. That's what I write here. Okay, now if you simplify, it is in the form of 0 to pi 1 minus x squared. Let us assume cos is x, so d of minus x. This minus you take outside, so minus, like that. So in that form it is there. So what is 1 minus x squared? So it is, that is equal to x into minus x cube by 3. Yes or no? So we follow the same procedure. Okay, so it will be equivalent to, if you simplify, it will be coming as cos cube theta divided by, that's what this one, right, by 3 minus x. Instead of x we have cos theta. You may ask why I put x cube minus 3, because this minus is there, no? If you bring this minus this side, it will be plus x cube by 3 minus x. That's what this one. Okay, so this will be equal to 0 to pi. So if you simplify, what you get is 4 by 3. So we got 4 by 3 here for this integration. This integration alone will give 4 by 3. So we remove this point, right, and substitute 4 by 3 instead of that 4 by 3. So this is what our P radiation. So that will be equal to I naught square pi eta divided by 3 dl by lambda whole square. This is what P radiated. Right? So I naught pi into eta divided by 3 dl by whole square. So what will happen? I write again, otherwise it is very confusing. P radiated is equal to I naught square pi eta by 3 dl by lambda whole square. We know eta is equal to 120 pi. Substitute that value. This indicates P radiated is equal to 40 pi square dl by lambda whole square, right? 120 pi, 120 divided by 340 pi into pi. So this is the power radiated by Hertzian dipole antenna. Very, very important formula, right? We have to solve a lot of problems by using this formula. So power radiated is 40 pi square into dl by lambda into I naught square. Sorry, here we have to keep I naught square. Okay, so next we find radiation resistance. We know P radiated is equal to I RMS squared R radiation. Fine. So this implies P radiation is equal to I RMS is 1 by root 2 of maximum value. So I naught square maximum is I naught. So R radiation, because I RMS equal to maximum of 1 by root 2. 1 by root 2 of maximum. Maximum is I naught value. Okay, so now we see this implies R radiation is equal to 2 into P radiated divided by I naught squared. So I naught squared, P 2 into P radiated is 80 pi squared into dl by lambda whole square. Numerator I naught squared, denominator I naught squared will be cancelled. So what we get is R radiation is equal to 80 pi square into dl by lambda whole square. This is another important equation. This is also used in a lot of problem solving session, right? Okay, so R radiation is equal to 80 pi squared into dl by lambda whole square. P radiated is 40 pi squared dl by lambda whole square I naught square, right? So this is radiation resistance, this is power radiated. Okay, so you see from this equation, right, we want antenna of large size. DL is a antenna size, right? If I want more radiation resistance, what is the thing? DL should be very high. So what is the conclusion we are making? the conclusion we are making is, right, we need a antenna with large R radiation are required for what? To deliver large amount of power to space. Yes or no? Why? You see, if the radiation distance is more, then only P is equal to I squared into R radiation, right? So R radiation should be high, then only we can deliver more power. So if R radiation should be high, DL should be very large. That is, the dimension of the antenna should be very high. So if you want to deliver more power, the antenna size should be large, right? So antenna with large radiation are required to deliver large amount of and moreover, more radiation distance means we can deliver more power. Okay, so that is the first thing we have to remember. Second thing is, if DL is equal to lambda by 20, it will indicate R radiation is 2 ohm only. You substitute DL is equal to lambda by 20, lambda cancel, 1 by 400. 1 by 20 squared is 1 by 400. So 1 by 400 is 1 by 80 by 400, 1 by 5. 1 by 5 is 0.2 into 3.14 whole square, that is approximately closer to 2 ohm, right? So which is small. This radiation resistance is very small, so it delivers very small power only. Right? So already we know that for HCN dipole antenna, DL should be less than lambda by 10. So HCN dipole for lambda by 20 itself, it is giving 2 ohm, means lambda by 10 it will give 4 ohm or 5 ohm only. So that resistance is very small. So the antenna cannot deliver much power. That's why HCN dipole is not used in the real time scenario. Right? So that is the another thing we have to remember. For HCN dipole antenna's main condition, DL must be less than or equal to lambda by 10. So this indicates R radiation is very small. Substitute DL is equal to lambda by 10. So for HCN dipole, DL should be less than or equal to lambda by 10. So I have taken lambda by 20. For lambda by 20, it is 2 ohm. So R radiation is very small. So this resistance, therefore this R cannot be matched with the transmission line, because transmission line has a characteristic impedance of generally 50 ohm. Yes or no? So but what is our antenna resistance? Antenna resistance is 2 ohm approximately, right? So what is the thing? Suppose let us assume that your transmission line is coming from our for example our TVs or something else. This is what our TV. So here we have a transmission line, and coming to our antenna, what will happen? Right? So this is having a 50 ohm, but antenna has 2 ohm. So impedance matching is not possible. So impedance matching is not possible means load and source impedance is not matched, so maximum power is not transferred. That is another problem, right? So these are all the things we must know. Moreover, we assume that a dipole has a uniform current, right? When I taught what do you call it, say dipole antenna, we know that dipole has uniform current, right? So this means that what is the meaning? It requires that the current should be non-zero at the end point of the dipole. This implies I should not be zero. I should be non-zero at the end point of dipole. At the endpoint of dipole. Why? Here you see, this is what dipole. Here the current is uniform current. So what is the thing? It has to accumulate charge here. If it is flowing like this is a dipole dl. So this is plus, this is minus, right? During positive half cycle, this will be full of positive charge. This will be negative charge. During the negative half cycle, this will become negative. This will be full of positive charge. So what is the thing? The current cannot be zero at the end point of the dipole, right? So this is practically impossible, right? Because the surrounding medium is non-conducting medium. Yes or no? But the end point is having a what you call charges. So this is somewhat contradictory, right? So, but why we are studying so dipole is not possible to use in the, we cannot use dipole in the real-time scenario. But why we are studying this? This is serving as a prototype model, right? If you are able to analyze dipole, we can analyze other antenna very easily. That's why we are studying this. I hope understand Hertzian dipole antenna clearly. If you have any doubt, please ask me in comment section. I will clarify. Thank you.